All right, buckle up, everyone. We're diving deep today. We're going to be talking large language models, LLMs, as the cool kids call them, and how to, how to make them even smarter, especially when they're put to the test.
Think of it as giving our AIs some extra study time.
Yeah, exactly. And get this, we're looking at some cutting-edge research from, well, a whole bunch of brilliant minds over at artilabs.ai, University of Toronto, oh, and Harvard, too. They're trying to figure out how to make these LLMs better by taking inspiration from, well, from us, from how humans solve problems.
It's pretty fascinating stuff. Instead of just making these models bigger, just throwing more data at them, this research is looking at how we can improve their performance, like right in the middle of a task.
Hmm.
And the best part is, no extra training needed.
So we're not just assuming our AI is like a super genius right out of the box.
Exactly. Um, it's more about giving them the tools to really think things through. And this new method they came up with, it's called multi-agent verification, or MAV for short. But before we get into all the nitty-gritty of how revolutionary it is, let's take a step back and look at a more traditional approach, something called best-of-n sampling.
Best of N sampling. All right, break it down for me. What's that all about?
Okay, so imagine you ask an LLM a question. Now, instead of it just spitting out one answer, it actually generates a whole bunch of different possibilities, like it's brainstorming.
Oh, I see. So it's like throwing a bunch of ideas at the wall and seeing what sticks.
Yeah, something like that.
Yeah.
But then, of course, we need a way to pick the best answer from the bunch.
Yeah.
Right, that's where the verifier comes in.
The verifier. Okay, and what exactly does this verifier do?
So the verifier is it's often another LLM, and it's basically tasked with scoring each of those answers, based on things like accuracy, clarity, that sort of thing. Kind of like a judge in a competition.
Oh, that's a great analogy. It's like having a panel of judges picking a winner from all the contestants.
Exactly. But now, this new research, it asks a really interesting question. What if, instead of just one judge, we had multiple judges, each with their own area of expertise? And that's where multi-agent verification, or MAV, comes into play.
Multiple judges. Okay, I'm intrigued. That sounds a lot like a panel of experts, each focusing on a different aspect of the answers.
Precisely. And each of these judges, they're called aspect verifiers in the paper, are basically other LLMs. But the key here is they're each specialized. They're focused on specific elements of the answer. Like one might be all about mathematical correctness, while another looks at logical flow, things like that.
So each judge gets to give their own verdict on how good the LLM's answer is. I like it.
And here's where it gets even more interesting. They don't give like a numerical score. It's a simple thumbs up or thumbs down.
Whoa, hold on. So no complicated scoring system, just a straight up yes or no.
Yep, that's right. And it's actually, it's very similar to how we give feedback in the real world, like online, for example.
Yeah.
Yes, this code works, or nope, sorry, this fact is wrong.
That's so true. It's like a much more human way of evaluating things, isn't it?
Exactly. And this binary feedback, it makes combining the assessments from all these different verifiers much, much easier.
Okay, so then the answer with the most thumbs up wins. That makes sense.
You got it. And this whole process, the generating multiple answers and then using these specialized verifiers to pick the best one, that's what they're calling Don MAV in the paper.
Bon MAV, I like it. Catchy. But the real question is, did it work? Did this new approach actually do better than the old ways of doing things?
Oh, they put it to the test. All right. They tested Bon MAV across 4 very different domains. We're talking math problems, general knowledge questions, even some graduate level reasoning tasks and coding challenges.
Wow, they really threw everything they could at it. So how did Bon MAV hold up? Spill the beans, give me the results.
Well, the results were actually pretty impressive. Bon MAV consistently outperformed both the traditional best of n with just one verifier and another method they were comparing it to called self-consistency.
So having that panel of diverse expert judges, it really does make a difference, huh? I bet there were some fascinating findings in there. What really stood out to you?
There were actually 2 findings that I thought were particularly striking. First, they found that even using less powerful LLMs as those verifiers, it can still boost the performance of much stronger LLMs, the ones actually generating the answers. It's like, I don't know, like a team effort. They called it weak to strong generalization.
That is fascinating. So even the like less experienced AI judges can still help the star student AI get even better.
Yeah, exactly. And then the second thing that really jumped out at me was, well, they found that they could actually use the same LLM for both generating those answers and then turning right around and verifying them too.
Whoa, hold on. So the AI is basically grading its own homework? That's
Yeah.
wild.
It is pretty wild. They called it self-improvement. And it really shows that these LLMs can be taught to critically evaluate their own work. Like step back and say, how could I have done that better?
That's amazing. Okay, so we've got this panel of specialized verifiers, each with their own expertise. But how do we know which experts to pick for each task? Like, we wouldn't want a poetry expert judging a math equation, would we?
You're absolutely right. That's where verifier engineering comes into play.
Verifier engineering. Okay, tell me more about that. What is that exactly?
Well, it's actually very similar to prompt engineering where, we carefully craft those instructions for the LLM. But here, it's all about selecting the right verifiers, the ones with the right expertise to handle the task at hand.
I see. So for like math problems, you'd want verifiers that are really good at spotting errors in calculations or, flaws in the logic.
Exactly. And for like coding tasks, you might choose verifiers that specialize in different programming languages or specific algorithms. It's still a very new area, this whole verifier engineering thing, but there's definitely a lot of potential for innovation there.
This is all so cool. It really feels like we're witnessing the emergence of a whole new type of AI, one that's all about collaboration and self-awareness. But I guess the big question is, what does it all mean? Like, what are the bigger implications of all this research? We've seen how it works, the impressive results, but where does this all lead?
Well, what's really exciting is that this research, it goes beyond just improving performance on tests.
Hmm.
It has some major implications for AI safety and oversight.
Oh, now you're talking. That's a topic that's always on everyone's mind these days, right?
Yeah.
We hear all these concerns about AI becoming too powerful. How does this multi-agent verification approach fit into that?
Well, think about it. If we can teach these LLMs to better evaluate their own output, or even better, have multiple AIs double-checking each other's work, it creates a system of checks and balances. It's like having a whole team of experts making sure everything is running smoothly and ethically.
So instead of just blindly trusting one AI, we're building in verification and accountability right from the start. That's huge.
Exactly. This could be a total game changer when it comes to building more trustworthy AI systems. Imagine, for example, using MAV to make sure that an AI medical diagnosis system is thoroughly checked by like a whole panel of AI specialists before it ever gives a recommendation to a human doctor.
Or having AI ethicists review articles written by an AI, to make sure there's no bias or misinformation slipping through the cracks. The possibilities are pretty incredible. It's not just about preventing problems, it's about enhancing the positive outcomes too. Like, could MAV be used to boost the creativity of an AI artist? By having other AI art experts offer critiques and feedback?
Absolutely. Think of it like AI jam sessions or AI art critiques. The future sounds pretty amazing, doesn't it?
It does. But, it's also important to consider the potential downsides too, right? Like, any powerful tool can be misused. Could this multi-agent verification approach be used for the wrong reasons?
That's a really good point. It's definitely something we need to be thinking about. If those verifiers themselves have flaws, they could potentially pass those flaws on to the LLM that they're evaluating. It all comes back to the need for responsible AI development, making sure that the people building and evaluating these systems are aligned with, with our values and goals as a society.
So careful and ethical design is crucial, especially as this technology keeps advancing. But overall, it sounds like you're pretty optimistic about the potential of MAV to be a force for good.
I am. I really believe that with careful planning and ethical considerations, this multi-agent verification approach, it really can have a positive impact on the world.
Well, you've definitely got me on board the MAV train. Before we wrap up, any final thoughts for our listeners out there?
As we keep pushing the boundaries of AI, it's important to remember that true intelligence, it isn't just about processing power or massive data sets. It's about collaboration, critical thinking, and learning from each other. And that's exactly what multi-agent verification embodies. It's about AI working together to achieve something greater than any one AI could on its own.
Beautifully said. And on that note, we'll leave you with a final thought to ponder. If LLMs could be trained to better evaluate their own work, how would that change the way we interact with artificial intelligence? What are the potential benefits and risks of this kind of the self-improvement? What do you think? It's a really big question to consider, isn't it? It feels like we're just at the beginning of something truly revolutionary here.
We are, and that's why it's so important to have these conversations now, while this technology is still developing. We need to be thinking about the ethical implications, the potential impact on society, all of it.
Absolutely. So for those of you listening, we encourage you to check out the research paper we've been discussing today. Dive into the world of multi-agent verification and explore these exciting new possibilities for yourself. And until next time, stay curious.
Yeah, it really makes you think, doesn't it? It's like, where do we even go from here? I mean, this could change everything.
I know, right? And that's exactly why it's so important to be talking about all this now, while it's still early days.
Totally. We need to be like super careful about the ethics of it all and the potential impact this could have, not just on, technology, but on society as a whole.
Absolutely. And I think that's where listeners come in. We need everyone to be thinking about this stuff.
Exactly. So to everyone listening out there, do yourselves a favor and check out that research paper we've been talking about. It's mind-blowing stuff, really. Dive into this whole world of multi-agent verification, and who knows, maybe you'll be the one to come up with the next big breakthrough.
That's the spirit. And on that note, we'll catch you on the next deep dive. Keep those brains buzzing.